Is about waves. Before we start, just think about the type of waves that you may already know. So hopefully the pictures gave you a bit of a clue there. We already know about water waves, we already know about microwaves, we already know about seismic waves, light waves, and you may have realised that the rays that come from the sun are also a type of wave. So in this lesson, you should be able to know by the end of this lesson, you should be able to describe wave motion. You need to be able to define wavelength and frequency, and you also need to be able to apply the relationship between wavelength, frequency, and wave velocity. So that basically means you need to learn an equation. The first thing you need to know about waves is that waves can transfer energy and information without the net movement of medium through which they travel. Whoa. Okay, what that actually means is energy can travel from one end of a wave to another. The actual particles through which it travels, or the medium through which it travels, doesn't move. It just vibrates. And there's always some kind of vibration involved or oscillation. And that's what passes that energy from one point to another on. So there's quite a few definitions that you need to remember and learn, and also you'll need to be able to label the wave diagram. And this is a transverse wave. So if we look at the first one, we've got the amplitude is from the rest point, and this is the rest point. And then you can measure that to either the top of the crest or to the bottom of the trough. And basically, that's just the amplitude of the wave. It's how much energy it's got. Okay, so if you were talking about sound waves and you had a louder sound, then that amplitude would be much larger. When we look at wavelength, it's from one point on a wave to the corresponding point on the next wave. So if we look at this one, you can see we've got a complete trough and a complete crest. You could also label it from crest to crest or from trough to trough. Now, the frequency of a wave is just the number of waves that pass a given point in 1 second. So literally just stand there and count. And the time period, well, that's the time it takes for one complete wave to have passed a particular point. So applying that relationship, as I said, it's a wave equation, and you need to learn this one. They won't give it to you for your GCSE. So wave speed equals frequency times wavelength. And you can see there I've added a triangle. You need to remember this equation, you need to be able to rearrange this equation and to obviously use it. So we're going to have a little practice with that. So pause the video here, have a little go at these questions using the wave equation, and then I'll come back and share the answers with you. First thing you should do when you're doing any calculation is to write down the equation. So in this case we've got wave velocity equals frequency times wavelength. And what I like to do is always put a triangle down, and that helps you straight away with the rearranging. So if you're not already familiar with these, you need to learn how to construct these triangles. So this line is our divide line, and this line is our times line. And so we just translate this frequency times wavelength. That's going to go at the bottom where our times line is. So we just place that in there, which leaves the wave velocity to go at the top there. So the first question, we're going to write down the information they gave us, and they gave us the frequency of 20 Hertz. They gave us the wavelength of 3 meters, and so this is a straightforward plug into the equation. So 20 times 3 will give us 60 meters per second, and make sure that you get your units correct. So question 2, again, write down all the information they gave you, which was frequency was what they were asking. The wavelength was 3 meters. Was 10 meters. The velocity was 8 meters per second. Remember that was meters. And so all we do now is we cover up what they've asked us, which is frequency. and that gives us velocity divided by the wavelength. So we just plug the numbers in. We've got 10 divided by 8, which will give us 0.8 Hertz. So question 3, again, they gave us frequency of 50 Hertz. The wavelength, this time that's the one they wanted to know, and the velocity was 300 meters per second. So again, we cover up the one they're asking, and we're left with velocity divided by frequency. So that's 300 divided by 50 Hertz, which gives us 6 meters. Okay, so the fourth one. Now, a fairly straightforward one, but the tricky thing here is to look for the units. So they gave us a frequency of 100 Hertz, and they gave us a wavelength of 50 centimeters. And this is where we have to remember there's 100 centimeters in a meter, so this is 0.5 meters. So we then just plug that in, 100 times 0.5 to give us 50 meters per second. And so there are the answers written down for you to have a little go. Hopefully you did really well on those, but lots of practice. So hopefully now you've understood the wave motion, you understand the definition of wavelength, frequency and also amplitude, and you're able to use the wave equation.